Welcome to the EPG Pathshala on Linguistics. I am Dr. Reenu Punus, affiliated to the Jawaharlal Nehru University, New Delhi. I will now be taking you through the module titled Introduction to Experimental Phonetics, Part 1. Phonetics is the branch of linguistics that is concerned with the production, transmission, and perception of speech sounds. Early phoneticians relied on their eyes, ears, and vocal organs to understand how speech is produced. One of the major turning points in the development of the field of phonetics occurred in the last decade of the 19th century, when phoneticians began using instruments to record the movements involved in the speech articulation and to capture sounds as acoustic speech signals. Early traditional research in phonetics, before the use of experiments, is often described as having been impressionistic in nature. Abercrombie was the first linguist to use the term impressionistic to describe a style of transcription that involved the absence of preconceived notions about the structure of the language being examined. However, impressionistic is also used in opposition to instrumental or experimental phonetics to refer to phonetic observations made based on the phonetician's own auditory impressions of the sound and without the use of technology. In this sense, then, impressionistic phonetics entails learning and cultivating a skill in identifying and distinguishing between a wide range of speech sounds. The primary focus of phonetic research subsequently became the identification of similarities and differences in acoustic correlates of categorical speech sounds and the great variability in their realization. The first half of the 20th century, therefore, witnessed the early development of research that later came to be labeled as experimental phonetics. Any systematic study of speech conducted using instruments to visually represent one or more aspects of the speech event and to obtain measurements comes under the purview of what is known as experimental phonetics. Impressionistic phonetics, as taught and practiced today, dates back at least to the early 20th century, but has been existent as a form of speech analysis much before then. Whereas experimental phonetics is a relatively younger field, the origins of which are often associated with the invention of the sound spectrograph in the 1940s. Much of the basic orientations and assumptions in experimental phonetics are based on those of impressionistic phonetics. In other words, some knowledge of impressionistic phonetics is essential for experimental phoneticians. The scope of impressionistic phonetics is curtailed by the abilities of the human senses. The use of instrumental methods in phonetic research has enabled the phonetician to extend, verify, and corroborate or question observations made via impressionistic methods. Experimental phonetics, as the name suggests, is concerned with how empirical studies in phonetics are carried out with the help of instruments. You have learnt in the previous modules on phonetics and phonology that a complete speech event broadly comprises three processes: production, transmission, and perception. This module will consider the main methods used to test speech production. Articulatory phonetics is the branch of phonetics that is concerned with how speech is produced or articulated by means of the human vocal tract. A basic knowledge of the physiology and anatomy of the vocal tract and other organs of speech is imperative for a thorough understanding of the processes that underlie speech production. There are many instrumental methods that have been used over the years to investigate the position and movement of the speech organs above the larynx. Some of the major ones that will be described in this module are as follows: X-rays, palatography and electropalatography, ultrasound tongue imaging, EMA, MRI. X-rays. One of the earliest methods that were used to capture images of speech articulators in a two-dimensional space is the X-ray. X-rays are electromagnetic radiations that have a wavelength between that of the ultraviolet and gamma rays. While X-rays provide great resolution for their images of the articulators captured, it is rarely used anymore in speech research owing to the lack of safety, high cancer risks, cell damage, etc. Palatography. Palatography is one of the earliest methods that were used to reveal details of the tongue-palate contact involved in the production of a sound. There are several systems of palatography, the earlier versions of which typically involved painting a dye or mixture of olive oil and charcoal on the tongue or the roof of the mouth, following which the participant is made to produce the desired sound and a photograph is taken. Such a record made through this method is called a palatogram. Another system of palatography involves the use of thin artificial palates made of materials like cellulose or vulcanite, which was custom made for each individual participant to fit his or her palate exactly. Before being put in the mouth, the artificial palate is dusted with a marking medium. After the target word has been pronounced by the participant, the palate is removed, and the areas on the palate where the marking medium has been wiped off due to tongue contact are noted. In order to create a permanent record of the palate after production of target word, a photograph is taken or a drawing is made of the palate as seen after use. Electropalatography, a later and more advanced version of palatography, has involved the use of artificial palates which contains electrodes that are fitted against the participant's hard palate. When any part of the tongue surface comes in contact with the electrodes on the roof of the mouth, electronic signals are transmitted onto an external processing unit. This is called electropalatography or EPG. EPG provides dynamic, visual, real-time information about the nature and location of tongue contact with the hard palate. The next method that we will be talking about is ultrasound tongue imaging, also known as UTI. Ultrasound tongue imaging is a relatively new technique which involves recording images of the tongue surface during speech using medical ultrasound machines. Sounds with the wave frequency higher than 20 kHz is called an ultrasound. A characteristic feature of any wave, light wave or sound wave, is that they reflect off the edge of an object or space that it comes into contact with. Reflected sound waves provide information about the boundaries of the objects that they touch. However, ordinary sound waves are not useful in providing such information. Ultrasound high-frequency waves are required to visualize the small structures and tissue boundaries on the human body, and this property forms the basis of the use of the UTI in the speech sciences. The tongue is a flexible muscular organ that shapes the air pockets in the vocal tract in different configurations in order to produce different consonants and vowels. The different consonants and vowels are characterized by the pockets of air vibrating at specific frequency ranges. In this method, tongue movements are recorded using a handheld ultrasound probe which is connected to a machine with a monitor that displays the tongue surface image captured using the probe. The probe is made of ceramic elements which are piezoelectric, that is, that they have a property of emitting electric charge in response to pressure or applied mechanical stress, in this case, sound pressure. Through the probe, the ultrasound machine transmits ultrasonic pulses one at a time in distinct directions that are called scan lines. When the pulse reaches the boundary between the tongue surface and the air above it, all the wave energy is reflected off, thereby enabling the production of an image of the boundary and surrounding objects. Despite being a non-invasive technique, UTI was for a long time underutilized in speech research, perhaps due to its heavy clinical use, primarily in hospitals, which tends to make it rather difficult to access. Over the last 3 decades, however, reduction in cost and improvement in the reliability of research measurements have resulted in an increase in the application of this method in speech science research. The next method that we will talk about is called the Electromagnetic Articulometer, or otherwise known as EMA. In this method, small metal transceiver coils are attached to the articulators. Electromagnetic detectors and alternating current magnetic fields are used to track the positions of the coils and thereby the movement of the articulators to which they are attached. While the earlier versions of this method could only record information about spatial location and track points along the mid-sagittal plane, the more recent versions are able to record information about 5 degrees of freedom and track points anywhere within the field range. EMA therefore offers excellent temporal and spatial resolution for tracking speech articulators. Temporal resolution is an indicator of the precision of a measurement with respect to time, and spatial resolution is an indicator of the quality and the ability of an imaging device to capture small details of an object. The major disadvantages of using this method are that it is expensive and sensitive to changes in local magnetic fields, air movements, and temperature. The next method that we will be talking about is the MRI, or magnetic resonance imaging. MRI is an imaging technique used in modern medicine to identify the soft tissues of the human body and in particular the anatomical structures of the human brain. The water and fat molecules in the body are made up of hydrogen atoms, among other things. Each atom, as we know, consists of protons, neutrons, and electrons, and the former two are said to form the center of an atom. The protons in the nuclei of these hydrogen atoms send out radio signals which form the basis of an NRI. Think of the hydrogen proton as a small bar magnet which spins in the body with their north-south poles aligned randomly. When the body is placed in a strong magnetic field, in this case the MRI scanner, the alignment of the poles of the hydrogen protons in the body's tissues changes to become more uniform. This uniform alignment of protons causes them to send out radio signals, which are in turn used by the MRI machine to develop images of the tissues of the body. As can be seen in the video on your screens, the image created by the MRI machine has black and white portions. The white portions are associated with high levels of electromagnetic energy, whereas the black portions represent a lack of electromagnetic energy. Apart from teeth, which do not contain hydrogen atoms and therefore cannot be captured by the MRI machine, the images of most other tissues associated with speech articulation can be constructed. MRI as a tool in articulatory phonetics has certain advantages in that it is a safe technique and constructs clear images of articulatory organs, including the rather inaccessible pharyngeal region. There are, however, some disadvantages too. Firstly, this technique requires that the subject be in a supine position, that is, with the body in a horizontal face-up position, which in itself could affect the regular functioning of some articulatory organs. Secondly, temporal resolution is low for recordings made via MRI, and high-speed MRI machines are not widely available yet. Thirdly, the procedure is noisy as they involve a high amount of electric current, and noise-cancelling fiber optic microphones are required in order to create audibly neat MRI recordings. Nevertheless, some amount of background noise is inevitable during such recordings. Fourthly, MRI scanners are expensive equipments which make it rather rare in speech labs and more common in hospitals, and the latter tend to be more inaccessible for those interested in using the machine to study speech science. To help you better understand how some of these methods have been used in phonetics research, here is a summary of a study of Tamil liquid consonants that involved a combination of several articulatory techniques. Narayanan et al. In their 1999 study used a combination of static palatography, magnetic resonance imaging, and electromagnetic articulometer to investigate both static and dynamic articulatory characteristics of the 5 liquid consonants in Tamil. Tamil has a rich liquid inventory, 2 rhotics, 2 laterals, and a 5th liquid, the phonetic nature of which is contested. The authors explain the advantage of using these 3 techniques in combination. MRI provides crucial information regarding the shape of the vocal tract. EMA provides valuable dynamic information about the articulators but are restricted to tracking only a few points along the mid-sagittal plane, which is an imaginary vertical plane that divides the body into right and left halves. Static palatography tells us precisely which parts of the tongue are in contact with which part of the roof of the mouth. The study involved one native speaker of the Brahmin dialect of Tamil, who is also the first author of that paper. A more detailed summary of the paper is available in the written version of this module. The MRI scan results in that study showed that the dental lateral involved a tongue tip contact in the dental region, a high posterior tongue body position, and a retracted tongue root. The tongue body for the retroflex lateral, on the other hand, was drawn upward, and the medial tongue closure was in the palatal region. Among the rhotics, the alveolar and the postalveolar had similar overall mid-sagittal tongue shapes. The postalveolar rhotic had a lower posterior tongue body than for the alveolar rhotic, and its narrowest tongue tip constriction was more posterior than for the alveolar rhotic. In the case of the 5th liquid, the anterior tongue body was pulled upward and well inside the oral cavity. The upward raised and inward pulled anterior tongue body created a pit-like cavity in the middle of the tongue body, which distinguished it from the other 4 liquids. The posterior tongue body was flat. Palatography results showed that the dental lateral was apical and characterized by lateral contact in the postpalatal or velar region, and a medial tongue tip closure at and behind the central incisors. The retroflex lateral was found to be subapical, with the underside of the tongue making a contact in the palatal region. The tongue-palate contact patterns for both the rhotics showed that both were apical but otherwise not very distinct. For the 5th liquid, the narrowest tongue constriction was in the palatal region, but the exact location was not consistent. There was no medial tongue-palate contact and central airflow occurred. A lateral contact has also been reported with the tongue body middle in the palatal region. The EMA procedure helped to measure several aspects of the 5 liquids, such as the horizontal and vertical movements of the articulators, the duration and peak velocity of constriction formation, and the release average curvature of constriction formation, and the release, which refers to the direction of the tongue tip movement. All of these measures revealed significant details about the articulation of the 5 liquids in Tamil, many of which individually and or in combinations with each other help to distinguish them from each other. We will now look briefly at how the authors of that paper measured and interpreted one of these variables, the horizontal X and vertical Y movements of the articulators, to better understand the usefulness of EMMA for articulatory phonetics. Results showed that the 5 liquids differed greatly in the XY, that is the front, back and the high-low dimensions, with respect to the tongue tip positions at peak constriction. The dental lateral, the pre-alveolar or alveolar rhotic, and the post-alveolar rhotic, as their names suggest, were found to be progressively back articulations in the front-back X dimension and showed little difference in the high-low Y dimension. The palatal rhotic and the retroflex lateral were considerably back articulations and also to some degree higher than the other liquids. In this module, we first looked at the development of the field of experimental phonetics briefly and its contrast with what is called impressionistic phonetics. Experimental phonetics, by definition, is concerned with the instrumental methods used in empirical phonetic research. Therefore, the methods that characterize each of the 3 branches of experimental phonetics, namely articulatory phonetics, acoustic phonetics, and auditory phonetics, that deals with the 3 processes involved in speech, namely articulation, transmission, and perception, form the focus of these modules. In this module, we focused particularly on articulatory phonetics. 5 main instrumental methods were discussed, namely X-rays, palatography and electropalatography, ultrasound tongue imaging, electromagnetic articulometer, otherwise known as EMMA, and magnetic resonance imaging, or MRI. Let's briefly summarize each of these methods. The X-rays are one of the earliest methods used in this regard, but it has more or less been scrapped from being used in speech research owing to a lack of safety, high cancer risks, cell damage, etc. Palatography and electropalatography are great methods if one is interested in examining the nature and the kind of contact and the extent of contact between the tongue and the heart palate. The ultrasound tongue imaging technique is a rather non-invasive technique and rather safe to use. But despite being a non-invasive and safe technique, it has been underutilized in speech research owing to its heavy clinical use and primary use in hospitals, which has made it rather inaccessible to speech scientists. All of that has changed in the last 3 decades owing to a reduction in cost as well as an improvement in the reliability of measurements that can be made with a UTI. And therefore, there has been a vast increase in the number of projects that have utilized UTI in speech research. Electromagnetic Articulometer, or EMMA, offers excellent temporal and spatial resolution as far as tracking articulatory points are concerned. However, it is expensive and is sensitive to changes in air movements and pressure and local magnetic fields, etc. The MRI, or magnetic resonance imaging, is also a fairly safe technique to use. However, there are certain disadvantages. Firstly, it requires that the participant be in a supine position, that is, in a horizontal face-up position, which makes it rather, one might argue, difficult for functioning of the regular speech organs. Secondly, it offers low temporal resolution. And thirdly, it's a noisy process. And fourthly, it is expensive and therefore found most commonly in hospitals rather than in speech labs. In the last section of this module, a study on Tamil liquids by Narayanan et al. In 1999 that employed multiple articulatory methods, namely the electromagnetic articulometer, static palatography, and magnetic resonance imaging was presented to enable you to have a better understanding of how these methods have been used in previous research. And as we could see from their results, using a combination of these different methods enabled the authors to interpret their results in a way that would tell us a lot more, or a lot in detail, about the way in which the 5 liquid consonants in Tamil are produced. So, we have come to the end of this module titled Introduction to Experimental Phonetics Part 1. I hope that the concepts have been clear. For further information, please visit the EPG Pathshala on Linguistics for the written version of this module and further references. Thank you.